Okay, let's see. First, the other four characteristics of waves will be reflection, refraction, diffraction, and interference. Okay, we start with reflection first. Okay, first idea of reflection. When waves are reflected, okay, we see the laws of reflection. Any wave that undergoes a reflection on a surface, the angle of incident must be equal to angle of reflection. Rule number one. Number two, the incident wave, the reflected wave, and the normal line must be in the same plane or same phase. Okay. So normally we will discuss about reflection by using examples of water wave to show how the reflection occur on the surface of water wave. Okay. Let's look at patterns of reflected waves. First idea, when you have a plane wave, see this is called plane wave. This straight line, right? It's plane wave. And the plane wave moves and the reflector happens to be a concave reflector. The reflected waves will take the shape of the concave reflector. So when plane waves are moving, when they are reflected, they take the shape of the reflector. So they become circular and they are converging to a focal point. Right? Next. If the plane waves are reflected on a convex surface, they will be taking the shape of that convex surface and they'll be diverging away from the surface. See, they are diverging away from the surface. So they take that shape. So what happened? This is the surface of reflector. When the plane waves, these are plane waves, the plane waves are moving towards the surface, they are reflected, they'll take the shape. So from the first diagram, second diagram, you should know by now, plane waves, once they are reflected from a surface of reflector, they will take the shape of the reflector. Next. Circular waves are a bit different. When a circular wave is reflected on a plane reflector, it's like bending the wave again. So the wave is actually making a U-turn and coming back again. All right? If you see the shape, you should know. The wave went and hit the reflector and coming back as the folded system that you see. This is the reflector. For reflection of wave, you see, let's say this is the wavefront crest lines of water wave, right? It's moving towards a flat reflector, the green one here. So this will be the incident wave moving towards the reflector and it is reflected. All right. So this is how the diagram look like for reflection of a wave. But this one is so simple. We are still talking about reflection of wave. So we can take example of light or water wave. See here. This is the wave which is moving towards the reflector. This is a plane reflector, right? So as the wave is moving, this is the wave, right? Like water wave. What happened? The line is called incident ray. This is the ray, incident ray. It's incident, okay? It will hit the surface and the imaginary line, the normal will come the picture. It's perpendicular, so the normal is here. So this is the incident angle between the incident ray and the normal are called incident angle. This is between the incident ray and the normal. Then the wave will be reflected. It follows the laws of reflection. According to the laws of reflection, incident angle must be equal, the amount to the reflected angle. The incident ray, the reflected ray, and the normal all must be on the same plane. All right, same plane. So how to sketch and show reflection of water wave, for instance? All right, see, first we have incident wave and incident ray. Then we draw the reflected ray with the same angle. And on the ray, we draw the wave. See here. This is the incident ray. All right. How to draw this? We just draw it perpendicular to the incident ray. This is the incident wave. Incident wave. We draw it perpendicular to the incident ray. This is the reflected wave. All right. This is the reflected wave, right? So, sorry, ray. This is a reflected ray. This is a reflected wave. So, the wave will be perpendicular to the ray. This is the reflected ray. So, the wave is perpendicular on the ray. This is the wave. The wave will be perpendicular on the ray. So, the idea is very simple. Always draw the ray first. On the ray, you will draw the wave. The wave, right? The wave will be perpendicular to the ray. So you have this is the ray and this is the wave. Okay, next thing to understand. When it is a reflection, before and after, the wavelength remain the same. The speed also remain the same. Before and after reflection, wavelength and speed remain the same. Direction will change. Frequency also will be the same. Of course, direction of wave propagation are changing. One thing will happen, damping. Damping for sure will occur. So reflection of wave. All the types of waves can be reflected. So any wave can be reflected. Reflection occurs when an incident wave strikes an obstacle and it is reflected. After reflection, frequency, velocity, and wavelength remain the same. All right, reflect, frequency, velocity remain the same. Only direction will change. Of course, it can go through a bit of damping. It follows the laws of reflection, where incident angle must be equal to reflection or reflected angle, and incident wave, reflected wave, and normal stays in the same plane. Right? Refraction of wave. Okay, what happened here? When a wave is moving through one medium to another medium with different densities, the wave undergoes refraction. Speed of the wave will change, but this is commonly occur for water wave and light wave because they pass through the medium, right? Sorry, for light wave and sound wave. For water wave, the refraction occur when the water moves from a deeper area to a shallow area or shallow area to deeper area. So effects of water wave refractions here, when they are refracted towards the normal when transmitted from deep to shallow water. So water wave will be refracted towards the normal when they are moving from deep water, deeper area to shallow area. And the same water wave will be refracted away from normal when they are moving from shallow to deep water. Yeah, during refraction, if water waves moving from, right, shallow water, right, means water wave moving from a deeper area to a shallow area. Frequency remain the same, wavelength decreases, velocity decreases. So water wave is moving from a deeper area to a shallow area. If the water wave is moving from a shallow area to a deeper area, frequency is the same, but the wavelength will become longer, increases, and velocity also will increase. So when water wave move from a shallow area to a deeper area, you see here, frequency is still the same. So whenever water wave undergo refraction, frequency remains the same. Only that when water wave move from shallow to deeper area, wavelength increases, velocity increases. All right. This is the basic idea of refraction of water wave. So if they are moving from deeper to a shallow area, they are refracted towards the normal. Okay. Deeper to shallow area, they are refracted towards normal. Shallow to a deeper area, they are refracted away from normal. Yeah. Next, this is the idea of refraction. You should know. Deeper area to shallow area, the wave is actually refracted towards the normals. Yeah. Okay, during refraction of water wave, for example, from deep water to shallow water, this is the incident ray, must be perpendicular to the incident wave. So this is the water wave incident moving towards a border. This is the border. the border between the deeper area and shallow area. So incident ray, this is the normal imaginary line perpendicular to the border. Incident angle is here, right? Then the wave goes through refraction, as I told earlier. When a wave moves from a deeper area to shallow area, it will be refracted towards the normal. Refracted towards, so this angle becomes smaller. So if you notice carefully, after a refraction, water wave, angle of incident will be bigger, angle of refracted angle, refraction will be smaller, right? The wave undergoes refraction. We see here, move from here to here. Now, incident angle, refracted angle, the wave is going here, and finally the wave is going here this way. See, this is the angle. So this is the refracted wave. Okay. If you notice, after refraction in the shallow water, wavelength decreases. So wavelength in a deeper area always bigger, shallow area smaller. Speed also decreased. Speed in a deeper area bigger, in a shallow area smaller. So a wave go through refraction from deep to shallow, refracted towards normal. Wavelength decreases in the shallow area and speed decreases in the shallow area after refraction.